Students, welcome back to the part 2 of lecture number 27. So, we are discussing about recurrent neural network, right, and this is very important for NLP, natural language processing. And what is that I told you? Recurrent neural network is basically a type of artificial network that use sequential data or time series data. Somebody is speaking or somebody is typing something, how it can predict what the next word will be. That is what this recurrent neural network does. Or somebody can predict what is the next sentence I am going to speak, that also is part of neural network. So, this is basically time series data. Remember, some time back we talked about it, right, sequential data, that is the time series data. Time series data can be in terms of speech, terms of images, terms of videos also. So, that is why you can combine CNN and RNN very easily, right. So, RNNs are commonly used for language translation. What is language translation? All of you know, right, language translation. Whenever you want to translate something like Chinese to English, German to English, language translation is very important, right. Google Translator does it. That is actually uses RNN network. You can also use in NLP, I told you, natural language processing, or you can also use speech recognition. Speech recognition is very important too for crime, very remember that. There are a lot of times videos are changed. So, there the how to detect the speech was given by the same person or it was altered, that is what speech recognition is very important. Or you can use for image capturing. And many more, it can be used for many more things. And we told you also that fundamental unit for recurrent network is what? Fundamental unit is the recurrent unit, which is nothing but a basically memory state or hidden state. Which is nothing but a hidden state that will memorize the previous steps. So, that can be used for the feed to the next step. It can be can be either external or internal recurring. Like in external recurring network, information can flow in both forward and backward directions, both from future and both from past. It can feed from both. That is what is the unique thing about external networks. Internal network is always feed forward, that is, it will be feed from input step by steps, right. So, it is basically a network which relies on this, and they are incorporated in many popular things like Siri, voice search, Google Translator, okay, many things it can be used. But first thing you should know what is the difference between okay, what is recurrent here? First let us talk about it. So, this is what I already explained, but let me tell you. So, one of the distinguished properties of recurrent network is this memory. It takes information from the prior inputs to influence the current input as well as the output. So, it is a neural network, right, one by one networks are present. So, it will take information, it will memorize the information from previous steps and then feed with the next step and also change the input and output for the next step, right. So, while traditional deep neural networks actually assume input and outputs independent of each other, they do not consider them. Input is giving feeding to the next layer, then next to next layer, and finally gives the output. So, they are independent, they are not dependent on each other, but here output of the current recurrent network depends on the prior elements or prior memorized states within the sequence. That is what happens in an English statement, sentence. If it has to predict the next word, it has to remember what has happened in the previous step. So, future events can also be helpful sometimes in determining the output of a given sequence, and that is why both kinds of networks can exist, external, internal. It is used to predict flood levels based on the past daily floods, like during this high tide and low tides. Every day or in a sometime high tides, low tides will happen on the oceans, and so it can actually take the data, time sequence data, and predict this flood level during high tide and low tides. It can also be used to solve temporal problems such as I told you, language translations, NLP, speech recognition, image capturing. It has already been incorporated in various things, right. So, now first thing let us talk about it. What is feed forward? I already explained to you, let me tell you again. In a multi-layer perception is a network formed by teaming up this perception, right. It is just like one input layer. So, you have input layer, you have seen that, right. So, then it gives feedback to the next layer. So, this is input, then this is first hidden layer, second hidden layer, and then you have output. But information is feed forward, right. Information is feed forward always. That is what. So, that gives the output. So, this is the way information is passed and then processed by these layers. That is what is called a feed forward neural network. This much probably you have understood, right. So, each layer can have large number of perceptron, that is what you see, and there can be multiple layers. But fact is that input layer sends output to the next layer, then next layer sends output to the next layer, and it goes on. That happens, and therefore, output does not depend on inputs, they are independent of each other. Sorry, output depends on input, but the values are not they are independent of each other. So, in RNN this is not done. This basically unlike DNN, this assumes input output independent of each other. Here output of RNN depends on the pair elements within the sequence, that is the major difference. Remember this, output of this network depends on the pair element within the sequence. So, that is why it has to memorize. There has to be memory step, right. That is what I told you, right. Main distinguished characteristic of recurrent network is this, they share parameters across each layer of network. In feed forward networks, there are different weights across the node, there are different weights, right. Here you can have different weights for each of these inputs W1, W2, W3, that is what happens. But in recurrent networks share the same weights parameters within the each layer of the network, and that said the weights are still adjusted by these back propagation things or gradient descent methods to facilitate processing, but within each layer weights are not changed. But in case of ANN or even CNN, within each layer you can even change the weights, right. So, recurring networks, neural networks leverage this back propagation through time algorithms to determine the gradients which are used later on by to determine or to basically optimize your data, right. So, that is what is the major difference. So, memory is the first step. Okay, this is the fundamental fundamental aspects of this. The fundamental reprocessing unit is this, the recurrent unit, which is nothing but a recurrent neuron. This unit has a ability to detect, maintain the hidden states, allowing the network to capture the sequential dependencies by remembering the previous input while processing. Okay. So, you can see that this is exactly this is the things actually it is using the previous states data here to predict the input. This is the weight, okay, and then it goes on. So, HT minus 1, HT plus 1, there are 3 sequences, and HT minus 1 gives the gives the input to the HT, same thing is for HT plus 1, correct. So, you can clearly see that these are the time series inputs xt minus 1, xt and xt1, correct, and these are your memory units LT minus 0, LT, LT plus 1, they are remembered, and these inputs are provided to this to the step, and then it is recalculated to provide the next one. That is what we are talking about it. So, let me explain you in this detailed manner. So, how this is done and in a next couple of slides, but before that I want to tell you one more important aspects. I think before I go ahead, what is known as a vanishing gradient problem in DNN. What is that? This is a very challenge problem, very big challenge in deep neural networks, and in fact this is this problem occurs very frequently in all kinds of DNN. What is the problem? Derivatives or slopes of the activation functions can become progressively vanishing small. Remember the slide I showed you, right? I can even go back to that slide and to show you that the derivative functions I showed you. Yes. So, these are the different transport activation function used. Remember that in every step of neural network we are using these activation functions to calculate the output, right. That is what is the key thing. So, this if the slopes or derivatives shown on the right side, right, the first order derivatives, if derivatives of slopes of these activation functions become progressively smaller as you move from one step to other steps, you can go from either forward direction or you can come from backward directions. What will happen? This will lead to problem in predicting the next output. You must be thinking why. Let me explain to you this. This phenomena in network is called a vanishing gradient problems. That is what it is called, because the slopes are, and this is very peculiar for mostly tan H functions and sigmoidal functions, very typically widely used. The gradient propagates through the layers and to calculate the next output. So, therefore, if they decrease significantly, so output and input, there will be not much difference, right, because the gradients are what is used to calculate the output. Remember, we sum it up, weights multiplied by the input values and add a bias, then you apply activation functions. And so, when you activate a function, you are using a slope to calculate the next step, right, or derivatives, right. So, if the gradients or slopes are very small, so change will be happening very small. So, the input and output will not have much difference. That is the key thing happen. This means that as they leave the output layer, return to the input layer, gradients become very small. As a result, weight associated with the initial levels, which are used to accommodate the small gradients, have little or no effect on the next output. This problem is more predominant in sigmoid functions, here sigmoid functions or tan H functions. This is more predominantly widely seen, because they have gradients values which varies between 0 and 1, or it can varies between -1 to 1. So, they can saturate between 0 and 1 or -1 to 1. In case of tan H, it is basically -1 to 1, in case of sigma it is 0 to 1, and these derivatives at various points can become 0. Okay, if you plot these functions, function may look like this, but this derivative may become 0. So, once this derivative may become 0, this is the function's derivative, they become 0, then what will happen? The gradients are very close to 0, this will not lead to any major change in the output, input and output will remain same. So, therefore, we are not going to get any extra advantage. That is what happens in case of gradient vanishing gradient problems, which we just now talked about it. Vanishing gradient problem is very widely seen, and this is very subtle in case of RNN. This problem is very certain and important in case of RNN. And one of the key indicator of how this can happen is that if you observe the model weights converging to 0 or stagnant, does not change much, right, as the cycle goes on or the things goes on for training epochs, during training epochs. Okay. So, this will also lead to this thing, and during training even loss functions will fail to decrease. Loss function is what is the difference between output and the actual values. If that fail to decrease during training process, then also you know that there is a problem of vanishing gradient, or you can also have a problem of you can detect by visualization of these. How do you take care of that? We can take care of using a thing called ReLU units. You remember that has a very important functions where x is 0 when value of the function is 0 when x is less than 0, value of the function is x when x is more than 0 or equal to 0, right. That is what is called ReLU, is equal to 0 when x is less than 0 is equal to x when x is more than equal to 0, right. That is what happens. This can be taken care of by using these functions, or it can be taken care of by using what is known as a short term long memory networks or gated recurrent networks in case of recurrent neural networks. These two can be used for that. I hope I could make you understand what is the problem is and why it can be, how it can be solved. So, this is mostly mostly found in case of sigmoid function or tan H functions, where the slopes of these functions vary between 0 and 1 for sigmoid or -1 to 1. So, what will happen is that slope may not change drastically or may be very small during the subsequent steps in the neural network, and this will lead to drastic effect on the output. Output will not change significantly. So, how the network will move forward, and that is why one can solve using different kinds of functions, activation functions like ReLU, or it can be you can use this kind of other kinds of RNN networks or variants like LSTM or GRU. Remember that I talked about it, right. So, that is what I talked about it. You see this function or this function, they have problems in terms of this. So, RNN networks can be also 4 different types. One is one to one, one to many, many to one, and many to many. What is one to one? This type of RNN network behaves same as a simple neural networks, okay, as it is known as a vanilla network. In this neural network, there is only one input, one output. You can see that you are giving only one input, single input, and you get a single output. This is a very simple network, which is called a vanilla network many times. But you have one to many. This type of RNN, there is one input, but many output possible. That is what happens in when you type something. You type one word, there will be many output possible, right. One of the most widely used example of the network is capturing image capturing. When a given image, can you predict a sentence having multiple words? That is what it is. When you have a given image given to you, can you predict a sentence having multiple words? So, that means you have one input, but it can give different outputs. That is called one to many. You can also have many to one also. In this type networks, many inputs are fed to the network at several states of the network process, and it will generate only one output. And this type of network is widely used in problem like sentimental analysis. If you have a stanza written by some of your friends, what kind of sentiment it reflects? Does it reflect passion? Does it reflect anger? Does it reflect some kind of a against some community or something? So, that can be detected. So, you have many inputs, but it gives you only one outputs, right. Wherever we give multiple words as inputs and predict only sentiments of the sentence as output. So, one sentence or couple of sentences has multiple words, what kind of sentiment it provides, that can be detected by RNN. Then last one is what is known as a many to many. In this type of neural networks, there are multiple inputs and multiple output possible. That is a very difficult to understand initially. For example, this will be used in language translations, right. You have many inputs. You are giving a one or couple of sentences from Chinese or Russian or Spanish. You want it to convert it to English or your mother tongue. So, what you will do? You are giving many inputs as many words and convert into many words in your mother tongue or other languages, and that is what is used. So, you can see this architecture. You have multiple inputs and they are connected provides multiple outputs. So, they are the different kinds of networks which are widely used in this what do I say, in this kind of neural networks or RNN networks. I think one more thing I need to talk about it. Yes. So, this let us talk about this variations of neural networks. I told you, right. So, first one is called LSTM. What is LSTM and how does it work? Let us see that. LSTM is basically, what did I tell you? This is nothing but a long short term memory. Short term memory all of you know, but what is the long short term memory? So, this is a variation of RNN network. Variation of RNN network, which is called long short term memory, LSTM. Let us put T also capital, LSTM. It is a network which was introduced by some gentleman like Sepp and Jurgen, and this networks was to address the problem of long term dependencies. I think I have already told you about dependencies. When you want to predict different words in a sentence or sequence, the next word depends on the previous one, right. Suppose if I write today, I am, then you can have many words possible, fine, good, bad words, right. How will detect? So, that means it has to remember previous sentence and previous words, and to have to do that it should remember, it should have a short term memory, but for long sequences. That is what is called LSTM, long short term memories. So, that means if I only say this word, these 3 words, it may not be able to detect my mood, how am I, whether am I good, bad, fine, or words, my health is okay or not, it cannot. But if I speak many sentences, it should be able to understand from that and write this. That is what is basically, in a layman point of view, what is known as a long short term memory. This is leads to long term dependencies, that is previous state what is influencing the current prediction, we want to predict the current value things, right. So, previous text which is going to influence the current predictions is not in the recent past. Not in the recent past. RNN may not be able to predict. So, that is why you have to use LSTM. So, one of the example is Alice is allergic ALL, allergic to what? Allergic to nuts, right. I write this sentence. So, next sentence is automatically write, she cannot eat peanut butter. Now, if it has a short term memory, it can only remember the last 2 words. NUT or maybe 2, then C cannot write this. It has to remember also allergic word, then only it can write C cannot eat peanuts butter. So, that is the essence of long short term memory. That is why I want to give you these examples. So, context of nut allergy can help us to predict the next sentence, that Alice cannot eat peanuts butter. Okay. So, therefore, LSTM has to do that. This is what LSTM has to do. To do that, LSTM has to have a specific architecture or structure. What is the specific architecture has? It has cells. Cells, remember that. LSTM has cells. And what these cells will do? These cells are hidden layers in the neural network, which can have 3 important gates. They are nothing but hidden layers. Okay. And these hidden layers have 3 parts. Remember, one is called input gate or 3 gates, input gate, and then output gate and a forget gate. Output gate and forget gate. These 3 things will be there in the hidden layer, and hidden layer is built in on in LSTM cells. So, these gates control the flow of informations, which is needed to predict the output of the network. For example, the pronoun such as she was repeated multiple times in the sentence for Alice, right. So, you might include them, exclude them from the cell state. That is what is done in case of LSTM. Alice is allergic to nuts, she cannot eat peanuts butter. So, you have a word called she. So, the gender pronoun is she, right, and this is used in the last sentence when I talk about Alice. So, that LSTM cell can actually remember. Okay. So, input gate will take the input, forget gate will not remember whatever is not required, only store those are important to generate the next state or next statements, and this is how actually the LSTM can solve the problem of vanishing slopes or vanishing derivatives, right. This problem can be solved. This is one of the major ways of do that. LSTM. Another network is known as GRU. GRU is another network. So, in a variation of RNN. Remember, these all are widely used in case of natural language processing. It is similar to LSTM, GRU. Let me tell you what is GRU. This is obviously U for input, and this is gated recurrent unit, gated recurrent unit. So, what is that? It basically similar to LSTM, as it works to address the short term memory problem. Instead of using cell state, they do not use cell state, which can regulate the interaction, it uses hidden states. This uses hidden states, all of them use hidden memory state. It is not only GRU or LSTM, hidden state instead of gates. LSTM using gates like input gate, output gate, forget gate. Instead of gates, this use hidden state. And so, but they do the functions like these gates only, and hidden states can store, they have the long term memory, long short term memory possible, and that is what actually it is widely used. These 2 variation, one is LSTM and GRU, they are widely used techniques in case of RNN. So, with this let me stop, and next lecture maybe we will discuss something new or something which we will discuss either from the deep neural networks, or we will move to the next set. because as I told you, as a part of deep neural networks, we have two aspects to be taught in this course. One is the normal discussion on the deep neural network, other one is advanced neural networks. So, some of the things which I showed you in the last part of the lecture. So, some of the things which we talked about. So, we principally finished the supervised learning thing of deep neural network, ML, NLP, CNN, RNN. Here we talk about LSTM and GRU, and bidirectional is basically the text from future and the past both together. That is what it is, not much difference from LSTM. So, we need to talk about unsupervised learnings. So, depending on the time frame I have to check it, either I will discuss in the deep advanced deep neural network sections, or I will discuss something here in the next lecture also. So, let me stop here, we will come back to the lecture number 28 in next one. Thank you.